Okay, question 6 from January 2007 paper. We've got an integration question coming up. So the diagram shows the curve with equation y equals root 3x plus 2. Okay, it's bounded by the shaded region. The shaded region is bounded by the curve and the lines x equals 0 and x equals 2. Find the exact area of the shaded region. Okay, let's start with part 1 before we move on to part 2. So I'm just going to make that smaller. Part 1. So we've got to find the exact area of the shaded region. So y equals 1 over square root of 3x plus 1, 3x plus 2, sorry. Okay, I'm just going to rewrite that because it comes in useful later. 3x plus 2 to the minus half. Lovely. Okay, so to find the area, integration, that's right, area here equals the integral between 2 and 0 of the square root, the negative square root of 3x plus 2. Negative square root, 3x plus 2 is the negative half, integrated with respect to x. So that's just well, we can think of this as reverse chain rule, really. And when we do that, we're going to get a third of increase the power by 1 divided by the new power. So 2/3 of 3x plus 2 to the half between 2 and 0. And if you're not sure about this step, try differentiating this now. And when you differentiate that, you should get this expression. And if you think that in an exam or something you're not going to be sure how to integrate, use the substitution u equals 3x plus 2 and substitute x for u, or substitute 3x plus 2 for u, and then you're going to have to change this dx to a third du, and then integrate by substitution. But I won't do that now. Okay, so when we do that, we find that we get 2/3 of 3 times 2 is 6, plus 2 is 7, so 2/3 root 7 minus 2/3 root 2, or 2/3 of root 7 minus root 2. Lovely. So that's the exact area of the shaded region. The second question, let's make it a bit bigger. Says the shaded region is rotated about the x-axis, so we are going to rotate that way. Okay. Yeah, we're going to rotate that way. Find the exact area of the volume of the solid formed, simplifying your answer. Okay. Find the exact area of the solid formed. Okay. So this is going to be a question which involves solids of revolution. Okay. So we're looking at the volume. So the volume is going to be the integral of pi y squared dx between the values of 2 and 0. Okay? So that's a formula we use for volume of revolution. Okay. Also word of revolution. Great. So what's y squared? Well, y was 3x plus 2 to the minus half, so that's just going to be 1 over 3x plus 2. Dx. Great. Okay, again, if you want to, maybe I will do a substitution this time, because you can do it by inspection, seeing that that's going to be lens, or we can use a substitution u equals 3x plus 2, and dx. When we differentiate that, we get du dx equals 3, so dx equals a third u. du, sorry. Okay, and we can also we have to change our limits. So when x is 0, u is going to be 2, and when x is 2, u is going to be 7. So v is now going to be the integral between 7 and 2 of u inverse 1 over u, u to the minus 1, sorry, a third of it times by du. Okay. Well, this constant can just come out of the integral sign, so that's a third of the integral between 7 and 2 of, I'm going to write this as 1 over u du. Well, we know what the integral of 1 over u is with respect to u. That's just ln of u between 7 and 2. Okay. We've changed the limits, so we can just plug them in. If you haven't changed the limits, you would have had to change your expression for u and substituted 3x plus 2 back in. Okay. So that's ln of 7 minus ln of 2. Well, that's just equal to a third. Then 7 over 2. Units cubed, if you want to be pedantic. But that's done. Solved. Just a quick note. Before, when I was in this question, I said that 3 times 2 plus 2 was 7. It clearly isn't 7, it's 8, so that should be an 8. That should be an 8. Similarly here, change the limits. That should have been an 8. That should have been an 8. That should have been an 8. Making that an 8, and that an 8. So our end answer should have been a third. Ln 4. Sorry about that, but we all make mistakes.